Yeah. So what is the bilinear transformation? Let us say this you don't have in your syllabus, but quadratic form is part of bilinear transformation. So we should discuss what is the difference. So if we have A is any matrix, any n by n matrix, Aij n by n, any matrix, and x is nothing but in n variables, x1, x2, xn. It may be given vertically or it may be given horizontally. So if it is given vertically, and y is nothing but y1, y2 to yn, n variables, A is an n by n matrix, then x transpose ay is called bilinear transformation. Bilinear. Why bi? Because two variables are there. X is there, y is there. Bilinear transformation. So, for example, if I take my x as x1, x2, A is equal to, let us say, ABCD, y is y1 by 2. Then what is the bilinear transformation corresponding to this? Then the bilinear transformation is bilinear transformation is x transpose ay. So this is x1, x2. Transpose means this column will become row into ABCD into y. Then multiply ax1 plus bx2. You know how to do matrix multiplication, row by column. Ax1 plus cx2. So ax1 plus cx2. bx1 plus dx2 into y1 by 2. Just matrix multiplication. First row, first column. First row, second column. Now multiply again. This will be ax1 plus cx2 into y1 plus bx1 plus dx2 into y2. So if you simplify this, what will you get if you simplify this expression? This will be equal to simply ax1 y1 cx2 by y1 plus bx1 y2 dx2 by 2. This is what is called bilinear transformation. This is x transpose A is bilinear transformation. If y is equal to x, there two variables are there. X is there, y is there. Suppose that y equal to x, then the bilinear transformation. One more before going to this. If A is symmetric, then I will call this as BT, bilinear transformation. E is called symmetric bilinear transformation. E is called symmetric bilinear transformation. In general, A need not be symmetric. It can be anything. If it is symmetric, then it is what is called symmetric. That bilinear transformation is what is called symmetric bilinear. For example, here what is our A when you look at it? It is ABCD. It is not a symmetric matrix. Symmetric matrix means these two should be equal. These two can be anything. These two should be equal. They are not equal. So it is not symmetric. If it is symmetric, then such a bilinear transformation is given a name, is what is called symmetric. If it is skew-symmetric, then such a bilinear transformation is called skew-symmetric bilinear transformation. Now, in this, if y is equal to x, then the symmetric bilinear transformation then the symmetric bilinear transformation is called a quadratic form. Is called quadratic form. Quadratic form. So this is the relation between bilinear transformation and the quadratic form, denoted by QF and symbolically denoted by Q of xy is equal to X transpose AX. What is X? X comma Y. A is symmetric. So if it is given vertically, we take transpose. If it is already given horizontally, if X is given horizontally, then quadratic form is XA X transpose. This should be transpose of this, only requirement. You know, X is X transpose transpose. X is nothing but X transpose whole transpose. These two should be transpose of each other. So if it is given vertically, then you take the transpose. Otherwise, matrix multiplication is not well defined. And if it is given horizontally, don't take a transpose because already it is in that form. Take here transpose. Here these two should be transposes of each other. Okay. Next. What is A called? Where A is given a name called? Where A is called? The symmetric matrix. A is called matrix of quadratic form. Matrix of quadratic form. Where the symmetric matrix A is called matrix of quadratic form. Then how to write? Let us see. I'll show you. So, given a matrix, problem, question. If A is equal to 1, 2, 2, 3, then quadratic form X transpose AX is. A is symmetric here. Then how to get? What is the solution? X, we take it as XY. Then X transpose will be horizontal. Now find out X transpose AY. X transpose AX. So X transpose is XY. Here it is 1, 2, 2, 1, 2, 2, 3 into X. So we get this as X plus 2Y, 2X plus 3Y, X. So multiply. This is nothing but X plus 2Y into X plus 2X plus 3Y into Y, which is X square plus 2XY plus 2XY plus 3X. So X square plus 4XY plus 3Y is the required quantity. Is the required quadratic. So how to get quadratic form? X transpose A X, where A should be symmetric. So then such a symmetric matrix is what is called matrix of the quadratic. I'll give you another question. Here luckily A is given to be symmetric. Find the quadratic form X transpose BX or X transpose AX, where A is 1, minus 1, 2, 3. Also, find matrix of quadratic form. Very important. Generally, students, they take it for granted whatever A that is there is the matrix of the quadratic form. But here, that A should be, the matrix of quadratic form should be symmetric. Earlier, we got symmetric matrix. We were given symmetric matrix. So directly, this is the matrix of quadratic form, as well as we got this. But here, this matrix is not symmetric. Therefore, first we have to get the quadratic form. From there, you have to find matrix of quadratic form. What is matrix of quadratic form? The symmetric matrix corresponding to the quadratic form. How to get, let us see. So most of the students doesn't know this. They take it for granted. A means A only. A is the required matrix of quadratic form. First option will be this only. Most of the students will write this. Y again expanding. So they think this is itself the quadratic form. No, it is not symmetric because these two are not equal. So how to get, let us see. First, let us get the quadratic form. X transpose AX. X transpose means this is XY. A means 1, minus 1, 2, 3. And again XY. Where X is XY. Fix it. Unless given. Now, what will you get next one? This we have to simplify. So how to simplify this? As before, get the quadratic form, multiply them. So this implies qx comma y. The quadratic form is denoted by qx comma. It will be x plus 2y minus x plus 3y x. So this is x plus 2y into x plus minus x plus 3y into y, matrix multiplication. So this will be x square plus 2xy minus xy plus 3y. So the quadratic form is x square plus xy plus 3y. This is the quadratic form. But we want matrix of the quadratic form. So what is the matrix of quadratic form? It has to be symmetric matrix. So matrix of quadratic form is, give some name B. How to get that matrix is x, y, x, x. Write the variables vertically, horizontal. Here xy, here xy. X into x, x square. So x square coefficient 1, that you have to write here. xy, yx. So these two, it should be symmetric. These two should be equal. These two are nothing but the coefficients of xy, yx. So what is the coefficient of xy is 1. This coefficient of xy, you have to divide by 1 by 2. Divide by 2. So here you will get 1 by 2. Here you will get 1 by 2. This is must. Because symmetric it has to be. So what you have to do? X into x, x square. Its coefficient you have to write. X into y, xy. Y into x, yx. Xy, yx same. So it should be same for symmetric matrix. So the coefficient you have to divide by 2. So that you have to write here and here. Same. Y into y square. Y square coefficient is 3. So this is the required symmetric matrix and is known as matrix of the quadratic. Is the matrix of quadratic form. So two models in this. If the given matrix itself is symmetric, previously, the given matrix itself is symmetric, then the given matrix A itself will be the matrix of the quadratic form. You can see, even if you write, like I have written now, even if you write, what is the matrix of the quadratic form you will get? Matrix of quadratic form is, what I should do? Just like I have done here, xy, xy, vertically horizontal, two variables. X into X, X square. What is the coefficient? 1. Y into Y, Y square. What is the coefficient? 3. Y square coefficient. XY coefficient. X into Y, XY. Here also there, here also. What is the coefficient? 4. You have to divide by 2. If you divide by 2, 4 by 2 is 2. Same you have to write here. And this is the matrix of quadratic form. Same thing we got it as the given question. In the given question, you are already given A is 1, 2, 2, 3. Same we got. So if it is symmetric already, this is itself the matrix of quadratic form. If it is symmetric, this is itself the matrix of quadratic form. If it is not symmetric, then first what you have to do, how to get the matrix of quadratic form? If it is not symmetric, first we have to get the quadratic form, then write the symmetric matrix. Make it symmetric using this. This is what is called matrix of the quadratic form. So we have seen given quadratic form, how to write matrix of quadratic form. Given matrix, how to get the quadratic. Both we have seen. Okay. Now, any doubts up to this? Any doubts ఉన్నాయమ్మా ఇక్కడ వరకు? ఇది 3 వేరియబుల్స్ లో ఉంటే ఎట్లా ఉంటుంది? సపోజ్ 3 వేరియబుల్స్ ఉన్నాయి. ఇక్కడ x and y ఉంది. XYZ ఉంటే ఎట్లా ఉంటుంది? అది కూడా చూద్దాం. So next question. If A is equal to, for example, 1, 0, 0, 0, 1, 1, 1, minus 1, 1, let us matrix. This is not symmetric. Find quadratic form. X transpose AX and find matrix of quadratic form. So here it is not symmetric. Given any question, first you have to see whether this is symmetric or not. How will you identify symmetric matrix? In the beginning we have discussed. This can be anything. Vertically opposite should be equal. These two should be equal. These two should be equal. This is the principal diagonal. Vertically opposite should be equal. These two 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 are equal. These two are equal. But these two are not equal. Therefore, it is not symmetric. So this cannot be the matrix of quadratic form. So matrix of quadratic form is different. Given matrix is different. If it is symmetric, this is itself the matrix of quadratic form. Okay. Then how to get the quadratic form? We have to take now based on the order of A. How will you know how many variables? If it is 3 by 3, take 3 variables. If it is 2 by 2, take 2 variables. So let X be equal to X, Y, Z. Then X transpose will be X, Y, Z. Write the quadratic form. X transpose AX. This is X, Y, Z. A 1, 0, 0, 0, 1, 1, minus 1, 1, 1. Multiply. This is X minus Z. Multiply. Y plus Z. Y plus Z. X, Y, Z. So multiply. X minus Z into X. This is Z. This is Z. Looking like 2. Plus Y plus Z into Y. Plus Y plus Z into Z. This will be X square minus XZ plus Y square plus YZ plus YZ plus Z. So the quadratic form is QXYZ is equal to X square plus Y square plus Z square minus XZ plus 2YZ. This is the required quadratic form. is the required quadratic. So if you're asked to find what is the quadratic form, this is how you can find. But we want matrix of quadratic. So matrix of quadratic form. How to write? 3 by 3 matrix, x, y, z, x, y, z. Suppose you are given x1, x2, x3 here. Write x1, x2, x3, x1, x2, x3. Sometimes this will be given to you. It is given, look at the variables. Then write the variables in this form. Now x into x square coefficient is 1. Let us complete diagonal elements. Y into y square, 1. Z into z square coefficient is 1. This is x into y, xy, y into x, yx. Xy coefficient here and here. Is there any xy coefficient? No. If it is there, we have to divide by 2 because it has to be symmetric. So xy coefficient is 0. 0 by 2 is 0, 0. Next, this x into z, xz, z into x, zx. These two should be equal. So what is xz coefficient? -1. So you have to divide by 2. So I'll get -half here, minus. Because it has to be symmetric. Zx, xz. Next, this is yz. Here zy. So what is yz coefficient? 2. 2 when you divide by 2, 1. So this is 1. This is the required, is the matrix of quadratic form. Matrix of quadratic form. Emma, is it clear? So with 3 variables we have done, with 2 variables also. So suppose the matrix is diagonalizable, then what is called canonical form, or it is called normal form, or sum of squares form. Sum of squares form. Corresponding to the quadratic form. Corresponding to the given quadratic form. Given quadratic form is given by lambda1 x square, x1 square, lambda2 x2 square, lambda n xx, where lambda1, lambda2, lambda n are eigenvalues of. So how to get canonical form? What is canonical form? If lambda1, lambda2, lambda n are the eigenvalues, then what is the diagonal matrix of A? All of you know. If A is diagonalizable, then this is the diagonal form. 0, 0, 0. Then if you apply x transpose dx, then you get only diagonal elements will be there, remaining all are zeros. You get this form. This particular form is what is called as the sum of squares form. The diagonal form, if the matrix A, the diagonal form of A is D, then this is how we get the sum of the squares form, where lambda1, lambda2, lambda n, they will become the eigenvalues of the matrix. So how to get sum of the squares form? Find out the eigenvalues of A, simply write diagonally, then you get what is called diagonal form of the required matrix, or this is also called canonical form or sum of the squares form. So how to get? First, given any transformation, you have to get matrix of the quadratic form. After getting the matrix of the quadratic form, find the eigenvalues, arrange them diagonally, remaining all zeros. So then you get this form. This you need not do directly. You can write lambda 1 x1 square, lambda 2 x2 square, lambda n x1. That is only square terms will be there. x1, x2, x2, x3, they will not be there because remaining all are zeros. If you arrange like this, then it is what is called as the canonical form or sum of squares form of. Okay, this is how you can get. There are many ways of getting this. This is one of the ways of getting the sum of the squares form. If you see in some other textbook, they may follow different methodologies for this. But this is the how somehow you have to reduce it to diagonal form or get the eigenvalues of A, reduce it to this. Okay, then you get what is called the sum of squares form. Then rank of quadratic form. A rank of quadratic form is defined as rank of matrix of quadratic. Rank of quadratic form, how will you find out? It is nothing but rank of the matrix of quadratic form. So given any quadratic form, we have seen how to get the matrix. How to get rank of the matrix? Reduce it to echelon. Then you get the rank of the matrix. That rank of the matrix is the rank of the, defined as rank of matrix of quadratic. That is rank of quadratic. Another way is also there. Rank of the quadratic form is also equal to, denoted by R, and is equal to number of non-zero eigenvalues. Number of non-zero eigenvalues. It may be negative, it may be positive. Number of non-zero eigenvalues of A is also called rank. How? Because rank of A is same as rank of D, because A is equivalent to D. Two equivalent matrices will have same rank. D is the diagonal form of A. Then how to get rank of A? It is equal to rank of D, because A and D are equivalent. D is the diagonal form of A. How to get rank? This is already in the echelon form. So lambda 1, lambda 2, lambda n are the real numbers. They may be 0. So how many non-zero rows are there? Number of non-zero rows gives you the rank. So now how will you identify the non-zero row? Based on the eigenvalues. If the eigenvalue is 0, that row becomes 0. So number of non-zero eigenvalues will give you number of non-zero rows. Therefore, that will give you rank. So there are two ways of finding rank. One is get the matrix of the quadratic form, reduce it to echelon form. Then you get what is called rank of the quadratic form. Find the rank of the matrix. Or if you know the eigenvalues, then count how many non-zero eigenvalues are there. That will give you a rank of the quadratic, denoted by R. Then what is called index? What is index of quadratic form? Is defined, denoted by small p, number of positive eigenvalues. Positive eigenvalues. Next. Signature. What is signature? These three are very important. Signature of quadratic form. It is defined as difference between number of positive eigenvalues and negative eigenvalues. Number of positive eigenvalues minus number of negative eigenvalues. Number of negative eigenvalues. Negative eigenvalues. The difference between number of positive eigenvalues minus number of negative eigenvalues will give you what is called as a signature. There is also one more way of finding this, 2p minus r. This and this will be equal always. Next, we have positive definite. So a quadratic form is said to be positive definite. positive definite if all eigenvalues are positive. So I will write like this: positive definite if all eigenvalues are positive. If all eigenvalues are positive, then it is called positive definite. A quadratic form is said to be semi-positive definite. Semi-positive definite if some eigenvalues are if at least one eigenvalue. If at least one eigenvalue is 0, remaining positive. Remaining are positive. So if eigenvalues are, some of them are positive, some of them are zeros, then it is called semi-positive definite. So when is it said to be negative definite? Negative definite if all eigenvalues are negative. If all eigenvalues are negative. Then negative semi-definite. Negative semi-negative definite or negative semi-definite. Semi-negative definite. If at least one eigenvalue is 0, if at least one eigenvalue is 0 and other eigenvalues, other are positive, negative. So the negative eigenvalues are 0 or negative, then it is called semi-negative definite. Then indefinite. Indefinite means some eigenvalues are positive, some eigenvalues are negative. If some eigenvalues are positive or positive, some are negative. So if they are mixed, then it is called indefinite. So this is how we find out nature of quadratic form. So what is the nature of the quadratic form is? So nature of quadratic form. It may be nature of quadratic. It may be positive definite, semi-positive definite, negative definite, semi-negative definite, indefinite. What is the advantage of knowing the nature? So, if this is the story about one quadratic. Suppose there are two quadratic forms. When are they said to be equivalent? You are getting questions based on that. So, equivalence. Two quadratic forms. Q1, Q2 are said to be equivalent on R if both Q1 and Q2, Q1 and Q2 have same rank, comma, index, comma, signature. If they have same rank, index, and signature, then they are said to be equivalent on R. Equivalent over R. This is the, and they are said to be equivalent on C if Q1 and Q2 have same rank. How about index and signature? No information. So if ranks are equal, then they are said to be equivalent on C. But if not only rank, index as well as signature are same, then they are said to be equivalent over C, over R, over C. Over R means all should be equal. And over C means if ranks are equal, sufficient. Okay. So now let us work out some questions based on. So suppose you are asked to find what is the nature of the quadratic form. How will you do? First you have to get the eigenvalues, then find out index and other things. Okay, take down this question. So I'll work out the question asking you to find the nature of the quadratic. Find the nature of the quadratic. Find the nature of quadratic given below. First, x square plus 2xy plus y. Second, you have x square plus y square plus z square, 2xy, 2yz, 2zx. But 3. Two xy, 2yz, 2zx. X1 square, 3x2 square, 3x3 square, minus 2x2 x3. Fine. Let us. What is the nature? Also write the canonical forms. Find the nature. Also find rank, index, signature, comma, canonical. With one shot, you will get all. Okay, so canonical forms corresponding to above quadratic. First one. So what is the quadratic form that is given? X square plus 2xy plus y. This is your Q of x comma y. First, we have to find the matrix of the quadratic form. So given quadratic form, first we have to find matrix of the quadratic. So matrix of quadratic form is, how to get the matrix? This is x, this is x, this is x into x, x square, y into y, y, x, y. Coefficient is 2. 2 divided by 2 is 1. Here also 1. X, y, y, x. Now, how to get the matrix of the quadratic form? You have to find out eigenvalues. Now, what is the nature? So, what are the eigenvalues? Any one of you can you tell me?
0, 2.
Very good.
0, 0, 2.
0, 2. Because we know shortcut. If all ones are there, how many zeros will be there? Eigenvalues are 0 and n. N means order. How many zeros? N minus 1. That is 2 minus 1, 1 0. That is the shortcut we have seen. Now, eigenvalues, based on the eigenvalues, we have to decide the nature. So, eigenvalue, one of them is positive, the other is 0. If it is positive and 0, what is the nature?
Semi-positive.
Semi-positive definite. So, since eigenvalues are positive 0, quadratic form is semi-positive definite. Here, luckily, I am applying shortcut. If it does not fall under shortcut, then how to find determinant A minus lambda equal to 0? That's the only alternative. Find the characteristic equation, solve to get the eigenvalues. We have seen shortcuts. Many shortcuts we have seen. If it's upper triangular, lower triangular, some of the rows equal to constant, some of the columns equal to constant, like that. Apply all the techniques. Somehow get the eigenvalues, or directly find the characteristic equation and find out. Now we want what is the rank of the quadratic form. Okay, so nature, this we have found. Nature of quadratic form is semi-positive. What is the rank? Rank of quadratic form is equal to, you can reduce this echelon form and find rank, but because we know eigenvalues, every time you need not find eigenvalues. You can reduce it echelon form. Then rank of A is the rank of quadratic form. So number of non-zero eigenvalues. How many non-zero are there?
Only one.
1 is equal to 1. Next, we want index. Index of quadratic is small p, number of positive eigenvalues. Positive eigenvalues. How many are there? Only 1. Number of positive ones. So, only 1 positive eigen. Next one, signature. 2 formulas are there, 2p minus r, or number of positive minus number of negative. So 2 into 1 minus 1, that is 1. 2 minus 1 is 1. They're not getting same, no? Rank is 1. 2 into 1. How many positive are there? 1. 2 minus 1 is 1. Let us see. Number of positive, it is not 2p minus r, please correct it. I'll try to give you another. Number of positive eigenvalues minus number of negative eigenvalues. Positive eigenvalues minus number of negative eigenvalues. Negative eigenvalue. Two n minus p form. What is n? Is order of the matrix. Order of the matrix. Order of the matrix is 2. 2 2s are 4. How many positive eigenvalues? 2. 4 minus 2 is 2. 2n minus p. What is n? Order of the matrix. Here also I'll correct. Number of positive minus number of negative. Suppose p of them are positive. How many will be negative? I'll try to give you the correct form. Total is n. P of them are positive. And they may be 0 also. So don't use this formula. Sometimes it will tally, sometimes it will not tally. Number of positive minus number of negative. What is now? How many positive are there? 2. How many positive? Only 1. 1 positive. No negative. So answer is 1. Please correct it. Don't use that. Number of positive minus number of negative. Number of negative. How many negative? No negative. So 0. How many positive are there? Only one positive. 1 minus 0 is 1. Okay. So directly use this signature. Next one, what do we want? Next one. That's all for the first question. Let us see. Question number 2. And we are asked to write what is the canonical form. So what is the canonical form for this? Canonical form. Yes. Corresponding to the quadratic form. Yes. What is the formula? Lambda 1 x square, lambda 2 y square. Because two variables are. You can take x1, x2, xy, depending on the options. Look at the options. In the options, if variables x and y are there, take xy. If x1, x2 are given, take x1, x2. If any other variable is given, y1, y2, take y1, y2. What are lambda 1, lambda 2? They are the eigenvalues. Or eigenvalues. Which are 0, 2. Then somebody may get it doubt. If I take lambda 1 as 0, lambda 2 as 2, then what is the canonical form? 0x square plus 2y is canonical. Okay. Suppose if I take lambda 1 as 2, lambda 2 as 0, because there is no particular order, then we get 2x square plus 0 as canonical. So how many canonical forms? 2 canonical forms. Sometimes you'll be asked to find how many canonical forms are possible. So we have to fill up two places, two eigenvalues. So 2 factorial. You have to select 2 eigenvalues, 2 places. So 2 factorial. So you will get them as 2 different eigenvalues, 2 different places. You have to fill up. So how many canonical forms you can get is 2 different eigenvalues, 2 different places. Permutations and combinations. If there are n objects and n different objects, n different places, they can be arranged in how many ways? N factorial ways, permutation combination. If there are n objects, places are r, then you can fill them in NPR ways. I will show you, I'll give you that shortcuts. Next, let us see. Next question. Second one. Second, third, fourth. You want me to do all or you select them? You select one question, I will do. Second, third, fourth, I will do one question. Remaining, you can, remaining 2 homework for you. You give me choice. Any one of them. Please take the opportunity. First come, first serve.
Third one. No?
Third one. 2xy, 2yz, 2zx. 2xy, 2yz, 2zx. If remaining students, if you are not getting anything, catch hold of Sarita, because she only has given the option. 2xy, 2yz, 2zx. This is the quadratic. First, we have to write the matrix of the quadratic. This is U. So, matrix of quadratic form. A is equal to, how to get xyz, xy. How will you know what is the order? How many variables are?
3 variables.
So 3 by 3. Earlier we had 2 variables, so 2 by 2. Now, here x into x, x square not there, 0. Y into y, y square not there. So diagonally 0. Next, this is xy position, xy, yx. These two should be equal. Xy coefficient is 2. So here 1, here. Next, This is XZ coefficient. XZ coefficient is 2. Divide by 2. Here 1, here. Because it has to be symmetric. This is YZ coefficient 2. So 2 by 2. This is the symmetric matrix and is the matrix of quadratic. Now, if you want rank, don't waste your time finding eigenvalues. You can simply reduce it echelon form and find. But because we want nature, I am doing eigenvalues. Otherwise, both will give you the same answer. You can reduce it echelon form. If you want only rank, reduce it echelon. So, because we want nature, we want eigenvalues. So, how to get eigenvalues? Let us see. So, eigenvalues, what is the characteristic equation? Determinant A minus lambda equal to C. So, subtract lambda diagonal. Minus lambda 1, 1, 1 minus lambda 1, 1, 1 minus. Expand plus minus this. So, minus lambda into minus lambda 1, 1 minus lambda minus 1 into 1, 1, 1 minus lambda plus 1 into 1 minus lambda 1, 1 is equal to 6. Expand. Then simplify. Minus lambda into lambda square minus 1 minus 1 into minus lambda minus 1, 1 plus lambda. Then do one thing. You can directly expand or take lambda 1 common, but I want to show the common method. So I'm doing like this. Otherwise, I would have taken lambda plus 1 common. So this is minus lambda cube plus 3 lambda plus 2 equal to 6. You have to get the eigenvalue. Actually, for this question, lambda plus 1 can be taken common, but I want to show you general method. How to get? We have to apply first inspection method. What is inspection method? How many eigenvalues will get? 3. So how to get them? Apply inspection method. That is, put lambda equal to 1 minus 1. Check whether it is 0. LHS minus 1 plus 3 plus 2, which is not equal to 0, which is RHS. RHS is 0. So if it is 0, then stop. Minus 1 if you take LHS. Minus 1 whole cube. 3 into minus 1 plus 2. This is minus 1 cube is minus 1, minus into minus plus 1. You are getting 0, which is RHS. Therefore, lambda equal to minus 1 is a root. That root is called eigenvalue. This is cubic equation. So we have to get remaining. How to get remaining? Apply synthetic division. Lambda cube coefficient minus 1. Next, lambda square not there. Lambda 3 constant 2. If any one of them is absent in between, you have to put 0. You know synthetic division, which you have studied in your 10th class. First, always you have to put 0. Minus 1 plus 0 is minus 1. Minus into minus plus 1. This is minus 1. This is 2. This is minus 2, 0. So if your answer here is correct, LHS equal to RHS, here you will get 0. This is the remainder. So you are dividing cubic equation by first degree. So you'll get a quadratic equation. 1 degree less you will get. Because cubic equation we are dividing by first degree. So this is lambda square coefficient. So minus lambda square plus lambda plus 2, 0. Now you can either factorize it or you can apply minus b plus r. Any one of the methods you can apply. Option is yours. It's factorizable, okay. Otherwise, apply minus b plus r minus b square minus 4ac by 2. I think you get lambda minus 2 into lambda plus 1. It is not factorizable also, don't worry. Apply quadratic roots formula. So we got 3 roots, minus 1. Already we got minus 1 as eigenvalue. 1 more minus 1 and 2. So we are getting, these are the eigenvalues of. These are eigenvalues. So here we are getting 2 eigenvalues, negative, 1 positive. If it is mixed negative positive, what is the nature?
Indefinite.
Indefinite. So nature of what?
Indefinite.
Indefinite. Why indefinite? Because some eigenvalues are positive. Eigenvalues are some eigenvalues negative. And some are positive. Next. Let us go for now. Rank. What is rank? Number of non-zero eigenvalues. So rank is equal to number of non-zero eigenvalues. Non-zero eigenvalues is equal to how many non-zero? 3. All the 3 are nons. So rank is 3. Next is index. What is index? Number of positive eigenvalues. How many positive eigenvalues?
Only one.
Only one. Which is 1. Next, signature. Number of positive minus number of negative. How many positive? Number of positive minus number of negative. Eigenvalue. Eigenvalue. So, how many positive are there? Only one positive. So, how many negative? 2 negative. Signature can be negative also. Some students, what they will do? After coming up to this, first option will be +1. Then suddenly they will get a doubt. Can signature be negative? Can signature be 0? Can signature be positive? Or is it necessary that signature should be always positive? These are the doubts you get in the examination. Now you will not get. So signature can be negative also. Signature negative shows that many negative eigenvalues are there than positive. If the signature is 0, that means number of positive eigenvalues is equal to number of negative eigenvalues. If the signature is positive, that means number of positive eigenvalues are more, number of negative eigenvalues are less. This is signature. Next one, ma. This is what we find in canonical form. What is canonical form? How many variables now? 3 variables. So how many canonical forms can we get? Sometimes we'll be asked to find the number of canonical forms. Physical. Without doing, I want to know. How many eigenvalues are there? -1, -1, 3. So what is the higher eigenvalue? 1, no? 2.
2 madam.
What are the eigenvalues? -1, -1.
2 ma.
2 madam.
2. So here, how many places are there? 3 places. How many eigenvalues are there? 3 eigenvalues. We have to arrange them. If you keep lambda 1 -1, lambda 2 -1, lambda 3 2, you will get one canonical form. If you take lambda 1 as 2, here -1, here 2, you will get another one. Like that, how many you will get? Without doing, we want. So apply permutations and combinations. So how many places are there? 3 places. How many eigenvalues are there? 3 eigenvalues. But how many are repeating? 2 are repeating.
2.
2 are repeating. So n is 3. N means number of eigenvalues. How many of them repeating?
2.
-1 repeating 2 times. So you might have studied in permutation combination with repetition. N factorial by number of times each eigenvalue is repeating. If they are different, if the eigenvalues are different, n places, n eigenvalues, n factorial. But they are not different, repeating. If they are different, n factorial is the formula. So, but here lambda 1 is repeating. So I will apply P1 factorial, P2 factorial, Pn factorial formula. You might have studied in your intermediate. So how many? 3 factorial. What is P1 means? Number of times an eigenvalue is repeating. So this is repeating 2 times. This eigenvalue is repeating only 1 time. So 1. So 6 by 2. How many? 3. What are those 3? Let us see. So this is one formula. Please try to remember. What are P1, P2, Pn? how many number of times they are repeating. Each eigenvalue is repeating. Number of times an eigenvalue is repeating. This P1, P2. If they are non-repeating, n factorial is the formula. That I will give you under the note. So this is 3. What are those 3? We want to know. So those 3 are, put lambda 1 equal to -1, lambda 2 -1, lambda 3, 2. We get minus x square minus y square plus 2x. Next we take lambda 1 as -1. We'll get lambda 3 to the middle one. All arrangements, possible arrangements. Lambda 2 is 2, lambda 3 minus. Then we
మ్యామ్ ఒకసారి 2 ఫ్యాక్టోరియల్ 1 ఫ్యాక్టోరియల్ ఎలా వచ్చిందో ఒక్కసారి చెప్పరా మ్యామ్?
చెప్తాను. Lambda 2 is 2, lambda 3 is minus. Okay, నేను రాయని. ఇది సెకండ్ వన్, ఇది ఫస్ట్ వన్. 3 ఫార్మ్స్ రావాలి. థర్డ్ వన్ ఎలాగా? 2 lambda 2 minus 1, lambda 3 minus. And the corresponding form is 2x square minus y square minus x. Okay. So how did I get this? నేను కింద ఫార్ములా ఇచ్చేస్తాను. ఇక్కడ వరకు అందరికి అర్థమైందమ్మా? సో ఇక్కడ నాకు ఎట్లా వచ్చింది అంటే, n అంటే ఆర్డర్ ఆఫ్ ద మ్యాట్రిక్స్ ఆర్ నెంబర్ ఆఫ్ వేరియబుల్స్. ఎన్ని వేరియబుల్స్ ఉన్నాయి? 3 వేరియబుల్స్ x, y, z. ఆర్ నెంబర్ ఆఫ్ ఐగన్ వాల్యూస్. టోటల్ ఎన్ని ఐగన్ వాల్యూస్ ఉంటాయి? ఏ ఆర్డర్ ఏదైతే అన్ని ఐగన్ వాల్యూస్ ఉంటాయి. సో n ఈక్వల్ టు 3. నెక్స్ట్ ఈ ఐగన్ వాల్యూస్ లో -1 ఎన్నిసార్లు రిపీట్ అవుతుంది? 2 టైమ్స్. ఇక్కడ P1 అంటే ఏంటి? నెంబర్ ఆఫ్ టైమ్స్ అండ్ ఐగన్ వాల్యూ రిపీట్స్. ఇది 2 టైమ్స్ రిపీట్ అవుతుంది. 2 అనేది ఎన్ని టైమ్స్ వస్తుంది? ఓన్లీ 1 టైం కనుక 1 టైం. ఇంతకు ముందర డిఫరెంట్ వచ్చేది 0, 2. ఇంతకు ముందర ప్రాబ్లంలో ఓన్లీ 2 ఐగన్ వాల్యూస్, 2 places because order is 2, n equal to 2. n eigen values, n places, n factorial. If they are different, only n factorial. If they are repeating, how many times each one is repeating? By that you have to divide.
Okay, ma'am.
ఇక్కడ నేను ఫార్ములా ఇస్తాను. సో వెరీ ఇంపార్టెంట్ అమ్మా, ఇది ఎక్కడ దొరకదు మీకు. నెంబర్ ఆఫ్ ఐగన్ వాల్యూస్ చూసుకోండి ఇక్కడ ఫార్ములా. నెంబర్ ఆఫ్ canonical forms. If A is an n by n matrix, and lambda 1, lambda 2, lambda n are eigenvalues. Okay. Then case 1. If lambda 1, lambda 2, lambda n are different or distinct, then number of canonical equal to n form. If they are all different. First case లో ఏమైంది? మనకి 0, 2 వచ్చాయి. 2 ఐగన్ వాల్యూస్, రెండు డిఫరెంట్. సో 2 ఫ్యాక్టోరియల్. 2 ఫ్యాక్టోరియల్ అంటే 2. సో మనకి అక్కడ ఏమొచ్చింది? 2x square plus 0y square or 0x square plus 2y square. 2 ఫార్మ్స్ వచ్చాయి. కానీ ఇక్కడ రిపీట్ అవుతుంది. సో కేస్ 2. If lambda 1 repeats, this is also called algebraic multiplicity, P1 time. Lambda 2 repeats P2 times. Suppose lambda k, not all are repeating. If they are not repeating, write only one factor. Those which are repeating, you count them. Then remaining not repeating, remaining non-repeating, remaining occurring ones, non-repeating. Then number of canonical equal to formula n factorial by p1 factorial, p2 factorial, pk factorial. మిగిలిన 1 ఫ్యాక్టోరియల్ కనుక నేను రాయట్లేదు, ఎందుకంటే 1 ఫ్యాక్టోరియల్ రాసిన రాయకపోయినా అదే రాసి. ఇది క్లియర్గా ఉందా అందరికీ? ఈ ఫార్ములా వెరీ వెరీ ఇంపార్టెంట్. సో బేస్డ్ ఆన్ ఐగన్ వాల్యూస్ యూ కెన్ నో హౌ మెనీ కెనానికల్ ఫార్మ్స్ యూ కెన్. వీటిని ఇట్లా కూడా డినోట్ చేస్తారు కొంతమంది. సపోజ్ 2 ఉన్నాయి కెనానికల్ ఫార్మ్స్, 2 కెనానికల్ ఫార్మ్స్ అయితే 2 పాజిటివ్ అవుతాయి, ఆర్ 1 పాజిటివ్ 1 నెగిటివ్, 1 నెగిటివ్ 1 పాజిటివ్. So if 2 canonical forms are there based on the eigenvalues, if they are different, so you can take lambda 1 as 0, lambda 2 as 2, first one, and lambda 1 as 2, lambda 2 as 0. It need not be 0, whatever value you get that. If they are not repeating, if they are repeating, divide it. For example, if eigenvalues are of quadratic, of matrix of quadratic form are 3, 3, 5, 2, 10. Number of canonical forms. చెప్పగలుగుతారా ఎవరైనా? ఒక 1 minute టైం ఇస్తాను.
Right. 60 ways, madam. 60 ways.
Okay, 5 factorial by 2 factorial. 5 into 4 into 3 into 2 into divided by 2. 60. ఏమో, సో ఇట్లా మీరు చూసుకో, ఇది ఒకటి ఇంపార్టెంట్. ఇంకా ఇక్కడితో మనం దీన్ని ఆపుదాం. మిగిలిన ఈ హోంవర్క్ చేయండి. మీకు రాకపోతే ఈ సరిత ఉంది కదా, ఆమెను పట్టుకోండి, ఎందుకంటే ఆమెనే ఈ చాయిస్ ఇచ్చింది. సో యూ క్యాచ్ హోల్డ్ ఆఫ్ హర్ రిమైనింగ్. రిమైనింగ్ ఈజీనే మీరు చేయగలుగుతారు. అందులో ప్రతి ఒక్క దాంట్లోనూ వితౌట్ క్యాలిక్యులేషన్ చూసుకోండి, విత్ క్యాలిక్యులేషన్ చూసుకోండి, ఎనీ కెనానికల్. సో నెక్స్ట్ కొన్ని క్వశ్చన్స్ నేను ఇవాళ పికప్ చేశాను, నేను అవి చేద్దాం అనుకుంటున్నాను ఇంకా, ఎందుకంటే అవి ఎక్కడ సొల్యూషన్స్ లేవు. సో ఇది ఒకటి చూసుకోండి. కెనానికల్ ఫామ్కి రెడ్యూస్ చేయడానికి చాలా మెథడ్స్ ఉన్నాయి, ఈజియెస్ట్ ఇది మనకి. సో ప్రతి మ్యాట్రిక్స్ కూడా మ్యాట్రిక్స్ ఆఫ్ క్వాడ్రాటిక్ ఫామ్ కాదు, అది సిమెట్రిక్ అయితేనే మ్యాట్రిక్స్ ఆఫ్ క్వాడ్రాటిక్. చాలా ఇంపార్టెంట్ థింగ్స్ డిస్కస్ చేసాము, చూసుకోండి క్లారిటీ. ఇది నాకు చాలా ఇంట్రెస్టింగ్ క్వశ్చన్. ఇది చూడండి, ఇది ఈ మధ్య ఇచ్చాను. లెట్ ఎఫ్ బి సిమెట్రిక్ బైలినియర్ ఫామ్ డిఫైన్డ్ ఆన్ దిస్ క్వాడ్రాటిక్ ఫామ్ అసోసియేటెడ్ విత్ దిస్. అంటే దీని యొక్క స్పెషల్ కేస్, ఇందులో మన వేరియబుల్స్ అన్ని ఈక్వల్ అనుకుంటే we get quadratic form. సో ఇక్కడ మీకు x1 x2 x3 అవుతుంది, ఇక్కడ మీకు వేరియబుల్స్ xy z ఉంటాయి, అవన్నీ ఈక్వల్ అయితే దెన్ ఇట్ విల్ బికమ్ లైక్ దిస్. సో క్వాడ్రాటిక్ ఫామ్ ఈస్ a special case of bilinear form. So that is the reason why both will be given. So it is symmetric bilinear form given by this. Then what is the value of this inner product? So చూడండి ఎంత బాగుంది క్వశ్చన్. ఎక్కడ ఎత్తిన దొరకదు సొల్యూషన్. ఇట్లాంటివి మీ సెట్ ఎగ్జామ్లో అండ్ సిఎస్ఆర్ ఎగ్జామ్లో గ్యారంటీ ఒకటి వస్తున్నాయమ్మా. ఇలాంటి ఇది కూడా కాన్సెప్ట్ బేస్డ్.
మ్యామ్
చెప్పమ్మా.
ఇంతకుముందు ఐగన్ వాల్యూస్ ఇక్కడ 3 3 5 2 4 అలా వస్తే ఒకవేళ ఫర్ ఎగ్జాంపుల్ 3, 3, 3 అండ్ 5, 5 ఫర్ ఎగ్జాంపుల్ అట్లా 2 టైమ్స్ రిపీట్ అయితే
మీకు ఇందాక వచ్చింది కదా, మంచి క్వశ్చన్. సపోజ్ ఐగన్ వాల్యూస్ కనుక ఏమొచ్చాయి 5 5 5 3 3 3 3 2 వేసుకోండి పోండి. ఏమవుతుంది దీనికి 5 ఎన్ని టైమ్స్ రిపీట్ అవుతుంది 3 టైమ్స్. ఇది P1 అవుతుంది. 3 ఎన్ని టైమ్స్ రిపీట్ అవుతుంది 2 టైమ్స్. ఇది P2 అనుకో. 2 తీసుకోవట్లేదు ఎందుకంటే 1 టైమే కదా, తీసుకున్న నష్టం ఏమి లేదు. ఇది P3 అని. టోటల్ ఎన్ని ఉన్నాయి 1 2 3 4 5 6. ఆన్సర్ ఏమవుతుంది 6 ఫ్యాక్టోరియల్ బై, ఇది ఎన్ని టైమ్స్ రిపీట్ అవుతుందమ్మా 3 టైమ్స్. సో 3 ఫ్యాక్టోరియల్. ఇది ఎన్ని టైమ్స్ 2 ఫ్యాక్టోరియల్ 1 టైం. దీన్ని 2 3 సార్ 6 అని చేయకూడదు తెలుసు కదా. ఇది కామన్ తీసేసి ఫ్యాక్టోరియల్ 3 × 2 6 ఫ్యాక్టోరియల్ అని రాయకూడదు. P1 ఫ్యాక్టోరియల్ ఇంటూ P2 ఫ్యాక్టోరియల్ ఈస్ నాట్ ఈక్వల్ టు P1 P2 ఫ్యాక్టోరియల్. ఇది ఎక్స్పాండ్ చేయాలి విడివిడిగా. ఇది 720 అవుతుంది. ఇది ఏమవుతుంది 6. ఇదేమో 2. 12 ఇందులో 6 టైమ్స్. సో 60 ఇస్తాం. రైట్. ఓకే అంతేనా?
ఓకే మ్యామ్.
రైట్ అమ్మా. నెక్స్ట్ ఇది చూడండి, ఇంత మంచి క్వశ్చన్ ఇది. సో దీనికి ఏం చేయాలి మనం? ఫస్ట్ వీ హ్యావ్ టు గెట్ ద మ్యాట్రిక్స్ ఆఫ్ ద క్వాడ్రాటిక్ ఫామ్. ఇలాంటి క్వశ్చన్స్ ఇచ్చారు. వాట్ ఈస్ ద మ్యాట్రిక్స్ ఆఫ్ ద క్వాడ్రాటిక్ ఫామ్? A ఈజ్ ఈక్వల్ టు సిమెట్రిక్ ఫామ్. సో ఇక్కడ వేరియబుల్స్ మనకి ఏమున్నాయి x1 x2 x3. ఇక్కడ కూడా x1 x2 x3 వేసుకోండి. నెక్స్ట్ ఇక్కడ మనం x1 × x1 x1 స్క్వేర్ లేదు కదా 0. x2 × x2 x2 స్క్వేర్ లేదు 0. x3 × x3 స్క్వేర్ కోఎఫిషియంట్ 1. సో ఫస్ట్ ఎప్పుడు డయాగ్నల్ రాసేసుకోండి సమ్ ఆఫ్ ద స్క్వేర్స్. నెక్స్ట్ ఇదేంటి x1 x2. సో x1 x2 x2 x1 ఇవి రెండు సేమ్ ఉండాలి. x1 x2 కోఎఫిషియంట్ 1 ఉంది. సో హియర్ 1/2, హియర్ ఆల్సో 1. హాఫ్ చేసుకోవాలి. నెక్స్ట్ ఇది x1 x3, ఇది x3 x1. ఇక్కడ 2 ఉంది అంతే కదమ్మా. సో ఇక్కడ 2/2 అంటే 1, 2/2 అంటే 1. ఇదేంటి x2 x3 కోఎఫిషియంట్ ఇక్కడ లేదు కదా. సో 0, 0/2 0 6. ఇది ఏమి ఇదేంటి మరి ఇన్నర్ ప్రోడక్ట్ ఏదో అడుగుతున్నాడు అంటే దిస్ ఈస్ డిఫైన్డ్ యాజ్ సమ్ వెక్టర్ అనుకోండి u బార్ కామా v బార్ ఈస్ డిఫైన్డ్ యాజ్, ఇక్కడ ఇది మనకి హారిజాంటల్ గానే ఇచ్చేస్తాడు. వెర్టికల్ గా ఇస్తే ట్రాన్స్పోజ్ తీసుకోవాలి. సో u బార్ a v బార్ ట్రాన్స్పోజ్. ఎందుకంటే హారిజాంటల్ గా ఇచ్చాడు కనుక దీన్ని వెర్టికల్ గా రాసి. సో one of them should be transpose, the other should be the transpose of the other. ఇది వెర్టికల్ గా ఇస్తే ఇంతకు ముందరలాగా ఇక్కడ ట్రాన్స్పోజ్ వచ్చి ఇక్కడ మామూలుగా వస్తుంది. ఇక్కడ హారిజాంటల్ గా ఇచ్చారు కనుక ఇక్కడ ట్రాన్స్పోజ్ వస్తుంది. వెర్టికల్ గా ఇస్తే ఇక్కడ ట్రాన్స్పోజ్. ఇది చూసుకోండి. u బార్ అంటే ఏంటి 3 4 మైనస్ ఇంటూ 0 1/2 1 1/2 0 0 1 0 1 ఇంటూ v బార్ ట్రాన్స్పోజ్ 2 1 7. క్యాలిక్యులేషన్ ఇదేమవుతుందమ్మా దీన్ని మల్టిప్లై చేస్తే దిస్ ఇస్ 3 × 0 0 4/2 మైనస్ this into this 3/2 0 0. Matrix multiplication 3 0 minus 2 1 0. This is 0 3/2 3 minus 2 is 1 2 1 0. 0 into 2 plus 3/2 into 1 plus 1 into 6. This is చూడండి ఆన్సర్ వచ్చిందా రాలేదు అక్కడ చూడండి. సో ఏం చేయాలి? ఫస్ట్ మ్యాట్రిక్స్ ఆఫ్ క్వాడ్రాటిక్ ఫామ్ రాసుకోవాలి. ఇది హారిజాంటల్ గా ఇస్తే u బార్ తీసుకోండి, u బార్ ట్రాన్స్పోజ్. ఇది వెర్టికల్ గా ఇచ్చారు అనుకోండి ఇట్లా ఇస్తే ఇక్కడ ట్రాన్స్పోజ్ తీసుకొని ఇక్కడ తీసుకోకండి. అర్థమైందమ్మా అందరికి? ఈ బిట్ గ్యారంటీ మీ సెట్ లో కానీ సిఎస్ఆర్ లో కానీ ఇలాంటి బిట్స్ వస్తున్నాయి. మీకు ఈ మోడల్ అర్థమైంది కదా. సో ఇట్లాంటి క్వశ్చన్స్ మీకు ఎక్కడైనా వచ్చినట్లయితే చెయ్యండి మీ ప్రీవియస్ సెట్ పేపర్స్. ప్రతి సెట్ పేపర్ లో ఒక క్వశ్చన్ వస్తుంది.
అంటే ఏదైనా ఒక వెక్టర్ ట్రాన్స్పోజ్ తీసుకోవాలి, మరొకటి యాజ్ ఇట్ ఈస్ తీసుకోవాలా?
అంతే యాజ్ ఇట్ ఈస్ తీసుకోవాలి. అంటే నీకు మ్యాట్రిక్స్ మల్టిప్లికేషన్ రాదు కదా లేకపోతే.
ఎస్ మ్యామ్.
M by
అంటే
N. So
ఫర్
matrix
ఎగ్జాంపుల్
multiplication.
ఇప్పుడు డిఫరెంట్ తీసుకున్నా ఏం కాదు మేడం, ఇది అటు అది ఇటైనా
ఎట్లా
అంతే వస్తుంది. ఓకే,
A is నీకు రాదు లేకపోతే
అవును.
matrix multiplication రాదు. Matrix multiplication is defined only when number of columns of first one equal to number of rows of second one. అది సాటిస్ఫై అయ్యేట్టు తీసుకోండి అయిపోతుంది. ఓకేనా?
ఓకే మ్యామ్.
ఇప్పుడు చూడండి ఇంకా కొన్ని ప్రాబ్లమ్స్ ఇక్కడ ఉన్నాయి. అసలు నాకైతే చాలా హ్యాపీ అనిపించింది ఇలాంటి క్వశ్చన్స్. సో మీరు ఈ క్వశ్చన్స్ చూడండి, ఈ క్వశ్చన్ ఉంది, ఇది హోంవర్క్ తీసుకోండి, ఇందులోనే ఉంటుంది. ఇది మీకు షేర్ చేస్తాను కదా షీట్, ఇది చేయండి. సేమ్ మోడల్ ఇక్కడ ఇంకా 2/2 ఉంది, అక్కడ 3/3. ఓకే, యూ బార్ ట్రాన్స్పోజ్ ఫర్ యూ బార్ ఏ వి బార్ ట్రాన్స్ అది తీసుకోండి. నెక్స్ట్ వన్ చూడండి, అదే ఎంత ఇంట్రెస్టింగ్ బిట్స్ అంటే ఈక్వలెంట్ అవుతాయి. ఇది ఒకటి గ్యారంటీ క్వశ్చన్. Q1 xy, Q2 is equal to x square plus 2xy plus y square. Then which of the following are true? ఇచ్చారు మీకు ఇక్కడ చూడండి. Q1 Q2 ఈక్వలెంటా, Q1 Q3 ఈక్వలెంటా, Q2 Q3 ఈక్వలెంటా, ఆల్ ద 3 ఆర్ ఈక్వలెంటా. సో ఎక్సలెంట్ క్వశ్చన్. ఇలాంటి క్వశ్చన్స్ మీకు CSIR లో వస్తుంది. ఇది తీసుకుందాం ఈ క్వశ్చన్. సో ఇక్కడే చేసేస్తాం. సో దిస్ ఇస్ ఎక్స్. దీనికి మనం వెన్ ఆర్ దే సెట్ టు బి ఈక్వలెంట్ ఎప్పుడవుతాయేమో, ప్రొవైడెడ్ దే హ్యావ్ సేమ్ ఇండెక్స్, సేమ్ సిగ్నేచర్, సేమ్ ర్యాంక్, 3 సేమ్ ఉండాలి. సో ఈ క్వాడ్రాటిక్ ఫామ్ తీసుకోండి. Q of x, y is equal to x1. ఇది Q1. దీనికి మనం ఫామ్ రాయాలి, మ్యాట్రిక్స్. దీని మ్యాట్రిక్స్ ఏమవుతుంది, ఇది xy, xy, x² y² ఏమీ లేవు, 0 0. xy కోఎఫిషియంట్ 1, సో 1/2 1. సో దీనికి ఐగన్ వాల్యూస్ కనుక్కోవాలి. వాట్ ఆర్ ద ఐగన్ వాల్యూస్ ఫర్ దిస్? దిస్ ఇస్ మైనస్ లాంబ్డా, క్యారెక్టరిస్టిక్ ఈక్వేషన్, a minus lambda equal to 0.
మేడం అలా కాకుండా 0 + 1/2 అంటే 1/2
1/2 వస్తుంది. మళ్ళీ ఇంకోటి దాన్ని ఏం చేద్దాం, ట్రేస్ కింద తీసుకోవాలి.
ట్రేస్
అట్లా
తీసుకున్నాను.
ట్రేస్ తీసుకోవాలి, అట్లా తీసుకోవచ్చు. డైరెక్ట్ గా మీకు వచ్చేస్తుంది మైనస్ లాంబ్డా ప్లస్ ఆర్ మైనస్ 1/2. సో లాంబ్డా ఈజ్ ఈక్వల్ టు √1/5 అంటే ప్లస్ ఆర్ మైనస్ 1. సో ఐగన్ వాల్యూస్ ఆర్ డిఫరెంట్, one positive, one negative. So what is the rank? Rank R is equal to number of values 2 వచ్చింది. సో ఇండెక్స్ ఏమొస్తుంది, P, నెంబర్ ఆఫ్ పాజిటివ్ ఐగన్ వాల్యూస్ 1. సిగ్నేచర్ ఏమొస్తుంది, నెంబర్ ఆఫ్ పాజిటివ్ మైనస్ నెంబర్ ఆఫ్ నెగిటివ్. పాజిటివ్ ఐగన్ వాల్యూ 1, నెగిటివ్ ఐగన్ వాల్యూ 1, 1 - 1 0. ఇది గుర్తుపెట్టుకోండి. దిస్ ఈస్ ఫర్ Q1 210 డేటా. నెక్స్ట్ Q2కి ఆల్రెడీ మనం చేసినట్టున్నాం ఇంతకు ముందర. Q2కి 0 2 వస్తుంది. ఇదే ప్రాబ్లం మనం చేసాం. ఇన్ Q2 data. What is Q2? Corresponding to this, what is the matrix? x² y², this is 1, this is 1. For this, what are the eigenvalues? 0 2. Shortcut. So what is the rank? Number of non-zero eigenvalues 1 ఉంది. This is 0. So what is index? Number of positive eigenvalues, that is 1. Next, number of that is signature. Signature is nothing but number of positive minus number of negative. Positive 1 ఉంది, negative అసలు లేవు ఇక్కడ కనుక 1 - 0. So 1 - 0 is 1. This is the data for Q2. So Q1 ఇక్కడ R2 వచ్చింది, ఇక్కడ R1 వచ్చింది. సో Q1 cannot be equal to Q2. Q1 Q2 ఆర్ ఈక్వలెంట్ అనేది కరెక్ట్ కాదు, ఎందుకంటే రెండింటికి సేమ్ ర్యాంక్ రాలేదు. ఇక్కడ ర్యాంక్ 1 2 వచ్చింది, ఇక్కడ ర్యాంక్ 1. ఓకే, ఆల్ ఆర్ ఈక్వలెంట్ అనేది కూడా రాంగే, ఎందుకంటే Q1 Q2 ఆర్ నాట్ ఈక్వలెంట్. ఇవి రెండు చూసుకోవాలి, Q1 Q3 Q2 Q3. సో వాట్ ఈస్ Q3? x² + y² + 3x. అంతేనా? ఏమో, ఈస్ దట్ ద వన్ ఐ హావ్ టేకెన్? Hopefully. Yeah, x square plus
2y square.
xy plus 2y. X square plus 3xy plus 2y. ఇది Q3. దీనికి చూద్దాం. So what is the matrix for this? This is xy. So this is 1, this is 2. This is 3 by 2, this is 3. So దీనికి either you can multiply by 2 and apply the shortcut, or you can directly find it. So 1 minus lambda, 3 by 2, 3 by 2, 2 minus lambda. You can multiply by 2 and then get for 2a and then divide by 2. Option is yours. So 1 minus lambda into 2 minus lambda minus 9 by 4 is 0. So then we simplify just the lambda square minus 2 lambda minus lambda is minus 3 lambda, 2 minus 9 by 4. 2 minus 9 by 4, 1 minus 1 by 4. So దీనికి ఐగన్ వాల్యూస్ ఎట్లా కనుక్కుంటాం? అప్లై మైనస్ b ప్లస్ r. So what will we get? Minus b plus r. So, yeah. So minus b plus r minus we have top for this. So that is 4 lambda square minus 12 lambda minus 1 0. Now apply minus b plus r minus b square minus 4a. Then what will we get here? Lambda is equal to 12 plus r minus b square minus 4ac by 2. 12 plus r minus root 160. So lambda 1, lambda 2. This is 12 plus r minus, this is 16 tens are 4 root 10 by 8. That is 3 plus r minus root 10 by 8. So 3 plus root 10 by 8, which is positive. 3 minus root 10 by 8 negative. Endukante 10 3.3 kada square root. So what is the rank for Q3? What is the data? Rank is 2 non-zero.
Ma'am, 3 plus root 10 by 4. 8 కాదు కదా ma'am. 2 కదా ma'am.
2. Okay, whatever it may be. It is positive. So P is equal to number of positive eigenvalues 1. Then we have in signature. What is the signature for this? Signature for this is S is equal to number of positive minus number of negative 1 minus 1 C. So Q1 data ఏమొచ్చిందో చూసుకోండి. Q1 for Q1 also just check the data. Q1 rank is 2. Q1 also you can see rank is 2. P is 1, signature is 0. Same 2 1 0, 2 1 0. So Q1 and Q3 are equal. So Q1 Q3 data is same. So Q1 Q3 have same rank, signature, index. Therefore they are equal. Q2 Q3 not same. Hence equivalent. Equivalent. Okay. ఇది ఇంకొక question. Interesting question. So like this, if you get in the exam, this is CSIR question. So you should be able to work out. You should not miss the bit. Quadratic forms. Chala simple question. Okay. Next question. Any two quadratic forms, it shouldn't. Which of the following are true? This is a CSIR question. So any two quadratic forms of same rank in n variables over R are isomorphic. This equivalent, when are they said to be isomorphic? Two quadratic forms of same rank in R over R are isomorphic. Eప్పుడు isomorphic అవుతాయి? Provided both are having same rank. Isomorphism అన్న equivalent అన్న ఒకటే గుర్తుపెట్టుకోండి. So if they are having same rank ఉంటే మనం over R చెప్పగలమా? When are they said to be isomorphic over R? Provided they are having same rank, same index, same signature. కానీ ఇక్కడ మీకు ఓన్లీ సేమ్ ర్యాంక్ వచ్చింది, సిగ్నేచర్ తెలీదు, ఇండెక్స్ తెలీదు. అవి కూడా సేమ్ అయితేనే ఓవర్ ఆర్ అని చెప్తాం. కనుక దిస్ ఈస్ ఇన్కరెక్ట్. 2 quadratic forms of same rank in n variables over C are isomorphic. కరెక్ట్. సేమ్ ర్యాంక్స్ ఉంటే ఆటోమేటిక్ గా ఐసోమార్ఫిక్ అవుతాయి. ఐసోమార్ఫిక్ అన్న ఈక్వలెంట్ అన్న ఒకటే. ఓవర్ సి అవ్వాలంటే ర్యాంక్ సేమ్ అయితే సరిపోతుంది. కానీ ఓవర్ ఆర్ అవ్వాలంటే ర్యాంక్ సేమ్ అవ్వాలి, ఇండెక్స్ సేమ్ అవ్వాలి, సిగ్నేచర్ కూడా సేమ్ అవ్వాలి. నెక్స్ట్, ఎనీ 2 quadratic forms in n variables are isomorphic over C. Any 2 quadratic forms we cannot say because they should have same rank. If they are having same rank only, they will be isomorphic over C. If there are any 2 quadratic forms, we cannot say they are isomorphic. Okay, because they should have same rank. Rank same లేకపోతే isomorphic కావు, అంటే equivalent కావు. Quadratic form in 4 variables may be isomorphic to, maybe అంటే maybe may not be. Can you give an example? So if there is an example where it in 4 variables is isomorphic to 10 variables, we say they are isomorphic to each other. So for this, I will give an example. Yes, maybe and not all the same, but we can create an example. In 4 variables, a quadratic form. In 10 variables, a quadratic form. Both should have same rank, same signature, same index. Can we create an example? If we can create an example in 4 variables and 10 variables, then we can say yes. So we have an example. So what is the example we are having? Let us see. I'll try to construct an example of a quadratic form having 4 variables, 10 variables, and are equivalent. Is there any example? That's what we want to know. So let us see. So I will try to generate an example where it is in 4 variables I want. So the matrix should contain 4 variables, is it not? That is 4 by 4 matrix I have to take, 10 by 10 matrix I have to get for the quadratic form. So I'll try to get an example. Here, for example, A matrix in 4 variables, 4 by 4 matrix. I'll take I4. I'll take known example. Any example we can give. We know. So what are the eigenvalues? It is in 4 variables. How do you know? 4 by 4 means 4 variables. This is I4. Identity matrix. What are the eigenvalues? 1, 1, 1, 1. These are eigenvalues. So what is the rank? 4. Because all are non-zero. How many positive eigenvalues? 4. So index is 4. Next, signature. Number of positive minus number of negative for this form. 4. Number of positive 4, negative are not there, so 4. So can we construct another 10 by 10 quadratic form having same data or not? If you are able to construct, we can say yes, they are isomorphic because 2 are isomorphic if they have same data. They are all real. So isomorphic over R. Nothing given means over R. If it is over R, over C, it will be given separately. If nothing is given, it means it is over R. That means same data. So I have to give another example of 10 by 10. So I will take 10 by 10. How I will construct is, I'll construct a block diagonal matrix. We have seen how to calculate for block diagonal. So I will take 4 here, 4 by 4. Remaining columns with the zeros. Here also remaining columns with the zeros. 10 by 10 matrix I will create. Here 4 by 4. Here I should have 10, 6 by 6. 6 rows, 6 columns. Is that not? So you can construct an example. Remaining all are zeros. Let us say it is a block diagonal matrix. So what will be the eigenvalues? Because it is in the that is diagonal form, eigenvalues of I4 will be the eigenvalues for this. So you take I4, remaining all zeros you take. Here 6 zeros, 0 matrix. This is 6 by 6 0 matrix. Here again 4 are there, so 6 by 6 0 matrix. Here 6 is there, 4 by 4. Take remaining all zeros. Then automatically eigenvalues will be the diagonal elements. Diagonal elements of I4 are 1 1 1 1. For block diagonal, eigenvalues of the block diagonal matrices will be the eigenvalues for the matrix. So what will be the eigenvalues? 1 1 1 1. It will have 10 eigenvalues. Remaining all are zeros. 6 zeros. because 10 by 10 matrix should have 10 eigenvalues. So these are the diagonal elements. So whenever it is a diagonal matrix, diagonal elements will be the eigenvalues. So for this, what is the rank? How many non-zero? 4. What is the index? How many positive eigenvalues? 4. So what is the signature? Number of positive minus number of negative? 4. No negative. So the data is the same for this. Therefore, they are isomorphic. And we are isomorphic. So you are getting in CSIR exam questions like this. Definite questions. They're very simple. So remember, two quadratic canonical forms or quadratic forms are isomorphic, provided they have same data. Over R means, over C means only rank is same sufficient. Remaining data need not be same. Okay, ma? So I'll
Ma'am.
close here. Yeah.
మ్యామ్ ఇక్కడ
చెప్పమ్మా.
రియల్ తీసుకోమంటున్నారు కదా మ్యామ్, డేటా ఏమి ఇవ్వకపోతే.
ఎందుకంటే ఈ మ్యాట్రిక్స్ రియల్ కనుక. ఎందుకంటే
మరి
ఇక్కడ ఏమి ఇవ్వలేదు. ఏమి ఇవ్వలేదు కనుక రియల్ అనుకుంటుంది.
నిన్న ఒకటి సమ్ లో విబిఏ ఇన్నర్ ప్రోడక్ట్ లో ఏమి ఇవ్వకపోతే ఫీల్డ్ కాంప్లెక్స్ తీసుకోమన్నారు కదా మ్యామ్. నిన్న మ్యామ్
అది ఆ కాంటెక్స్ట్ వేరు కదా, ఇన్నర్ ప్రోడక్ట్ ఇది క్వాడ్రాటిక్.
అదే మ్యామ్ ఇన్నర్ ప్రోడక్ట్ లో ఎప్పుడైనా ఏమి ఇవ్వకపోతే కాంప్లెక్స్ తీసుకోవాలమ్మా.
కాంప్లెక్స్ అని లేదు. ఏ క్వశ్చన్ లో చెప్పాను కాంటెక్స్ట్? ఆ క్వశ్చన్ రేపు పోస్ట్ చేయి. నాకు టైం అవుతుంది కదా. నాకు రేపు క్లాస్ స్టార్టింగ్ లో చెప్పెట్టదు ఏ కాంటెక్స్ట్ లో చెప్పాను అని. ఏ కాంటెక్స్ట్ లో చెప్పాను అని నాకు ఆ క్వశ్చన్ పెడితే నేను అక్కడ డిస్కస్ చేస్తాను. సో టుమారో వీఆర్ గోయింగ్ టు స్టార్ట్ జోర్డాన్ canonical forms. సో
మేడం ఒకసారి కాంప్లెక్స్ లో ఏమేం సేమ్ అవ్వాలి మేడం? ఐసోమార్ఫిక్ అవ్వాలంటే
ర్యాంక్ సేమ్ అయితే చాలమ్మా. ఇక్కడ
Okay,
రాస్తాను.